The best time to learn Spring Boot was a year ago, but the second best time is right now. If you want to start your journey with Spring Boot, you are in the right place. Today we will go over the core concepts of Spring Boot and create your first simple application. If you are looking for a complete Spring Boot course, I just uploaded the first part of Spring Boot Fundamentals course on my Spring Boot Academy. You can check it out after watching this video, link is in the description. Okay, let's start from the beginning. I will assume that you never worked with Spring Boot or Spring Framework before, but it would be nice if you have some basic knowledge of Java concepts like OOP and core functions. Also, you have to have a basic knowledge of build systems like Maven or Gradle and a working IDE with Maven and latest Java JDK installed. If you have IntelliJ, for example, the Maven and JDK are already pre-installed, so you don't have to worry about anything else. Spring Framework and Spring Boot are often used interchangeably, but they are not quite the same. Spring Framework is a framework for building Java applications in general, not only web applications. It is popular for being modular and has many different modules designed for specific tasks like database integration, dealing with web requests, logging, and security, and so on. It is very powerful but requires a lot of configuration before you start your development. This is where the Spring Boot comes. Spring Boot takes care of the configuration for web applications and provides sensible defaults and out-of-the-box functionality like embedded web server. This is why 99% of the time when you create a new web application in Java, you use Spring Boot for it. Okay, so how do we create Spring Boot projects? You have to go to the start.spring.io and use the Spring initializer. Here we set basic information about our project, like build system or metadata. I will select Maven as the build system, Java as the implementation language, and I will choose the Spring Boot version. Right now, the latest stable Spring Boot version is 3.5.4. Okay, let's select our project metadata. So group ID is basically the ID of the organization that owns our project, and it follows the reverse domain pattern. So example.com becomes com.example. I will just use my own domain, so dev.kalbarczyk. You can use your own, that doesn't matter. Artifact and name are basically the name of our application. We can leave it as it is. Also, this description is self-explanatory. And the package name is the combination of our group ID and our artifact. So we leave it as it is. Packaging will use jar, and I will use Java version 21 because it's the latest long-term support version. We also can choose some dependencies here, static dependencies, and basically Spring team prepared a lot of starter packs for our application. These dependency starters are basically collections of curated dependencies, so libraries and frameworks that often are used together and that are tested for the exact version of Spring Boot you are using. So you have 100% guarantee that they will work. I will search for the Spring Web and add it to our application, and I will generate new project. After generating this project, you can use whatever IDE you like to open this project, for example, Visual Studio Code or Eclipse, but I will use IntelliJ. When we look at this project, when we open it first time, we see few files already. So we have the .idea that has some configurations for the IntelliJ. We don't care about that. Next, we have .mvn, which basically is a configuration folder for the Maven wrapper. Maven wrapper is a local version of Maven that is used for your project. Here in the Maven properties, for example, see this local version of Maven. And Maven also has two other files in our project, mvnv and nvnv.cmd. These are basically shell scripts that download the selected version of Maven. And the .cmd is for Windows, and this one is for Unix-based systems, so Linux and Mac. We also have Git attributes and Git ignore. These are Git files. We don't care about that in this video. There's also some help of Markdown that has some useful references for learning. We can skip that for now. And there is also pom.xml. POM stands for Project Object Model and contains important information about our project like metadata and project dependencies. Here we already can see our starter dependencies. The test dependency is added automatically, but we added the starter web before that, right? When creating the project. Okay, there's also another very important directory in our application, in our project, and that's the source directory where we write all of our code. It has two folders, main and test. In test, we obviously expect to find tests for our application. We won't cover this in this episode, so we will skip that for now. And in main, we have all the code that we write for our application. In Java, we have all our Java code, like the name suggests. So all of the Java code of our application goes here. And in resources folder, we put everything else. So like static HTML, configuration files, JavaScript, images, everything that is not Java goes to resources. And in resources, we also have application properties when we can set some like configurations that we don't want to hard code in our application. We can change application name. We also can, for example, change here server port. And we can also define our own properties like custom greeting, for example. But we will skip that for now. That's not like the topic of this video. And this is like the demo application is the entry point of our application. So it's like the main class in a normal application. And the name is generated obviously from the name of our application. So if you would have, for example, store application, it would be store application here. We can run this application in IntelliJ using the play button. The shortcut on Mac is Control R. And if we scroll here, we will see that Tomcat was initialized on the port 8080. So now if we go to the localhost 8080, we see that our application was loaded. But we obviously didn't put anything yet, so we get this white label error page. Okay, now that we know what Spring and Spring Boot is, we know how to create new project and what the project structure is, let's create our first controller. What is controller, you ask? In Spring Framework, we use something called MVC to structure our application. I made a separate video about this topic, so you can watch this after this video. In short, MVC stands for Model View Controller. A model handles the logic of our application and the state, and view is responsible for what the user sees and the user interaction. And the controller is the middleman that gets requests from the view, and then after interacting with the model, returns response data to the view. Most often in modern applications, a view is implemented as a separate application using modern JavaScript frameworks like Angular or React. But we can also create a full stack application in Spring Boot using the Thymeleaf template engine. I don't want to complicate things for you in this video, so I will only create a REST API that some other frontend can't interact with. So we can focus on the controller and the model part of the application. I will now create two new folders in our package. So package model and package controller. Okay, and I will create a user model that will represent users in our application. For example, let's make it a record for simplicity. Okay, and add some long ID, string username, and string password. Okay, now that we have our model, we can create our controller. So Java class and user controller. Right now, Spring doesn't know that this class should be registered as a controller. So we need to add annotation that will tell Spring that indeed this is a controller. Annotations are basically a way to give Java compiler some additional information, and annotations can be used to, for example, generate some code during compilation. And here we have two options. We can use controller and also REST controller annotations. Not repository, but REST controller. The controller is used for full stack applications, so we are going to stick with the REST controller. Now we need some endpoints for our application that the end user can interact with. For example, let's say I want to get all of the users in our application. So I'm going to create a new method, public list user, import class, get users. Okay, And because we don't have any like repository or database of users in our application, for now, I'm just gonna create list users and equals list of a new user, okay? And ID 1, user 1, and password, okay? Now I will return this users list, okay? And right now, Spring Framework still doesn't know that this method is endpoint to our application that the web application could interact with. So we need to add another annotation. And we here have few options depending on the HTTP method that we want to handle with this method. So we get, for example, get mapping. We also have post mapping and delete mapping, and so on and so on. Get is used when the user wants to get some data from our application. Post is used when we want to add some data, and delete is used when we, for example, want to delete something from our application. So it makes sense in this example to use get mapping because our user is getting list of users in our application, right? So I'm going to use the get mapping. Let's run our application again right now. Okay. And let's go again to the localhost. And we get our user printed nicely here. Basically, to test APIs like this, it would be nice to use some tool like Postman, for example, because the browser is only sending the GET request. So we could not test the post, put, or delete HTTP methods. But for this video, the browser will be enough. Okay, we have our first controller ready. But I would like to move this list of users to, for example, some separate container that will handle storing data in our application. To do that, we will add another layer to our application using the service repository pattern. Repository is responsible for storing the objects in our application, and most often that is done by integration with a database. Service, on the other hand, is meant for dealing with the business logic of our application. And by business logic, I don't mean exactly business like money making, but I mean the logic of our application, like validation and error handling, for example. So let's create a repository and service folders in our project. So repository and service. And I will create new class called user repository. Okay, that will have private list of users, and list of, for example, admin. Can add some more users here. Okay. We get some example list, and I will create also a method public list user, get users, and return users. But I will actually return collections unmodifiable list users. We do that because we don't want anyone to modify this list outside of this user repository, because user repository is responsible for everything that happens to the this group of our users that are in our application. So for example, when you want to add user, remove user, modify user, you do this only by interacting with the user repository. Obviously, we don't have any database right now, database connection, so I will just stick to this in-memory list for our repository. And I will also create a service. So I'll create user service, okay? And this service needs our repository here so we can call it by the service, right? So I will get here. So I will give here private final user repository, okay? And in the constructor, I will use something called dependency injection. So we will just inject this dependency, so this user repository class, to our user service. And now I can create another method and get users like this. We need to import that. Okay, also import that. Obviously, in normal application, there would be some more business logic. Right now, this user service is kind of redundant. But for example, when we will be adding some user, we would want to add some validation, and the user service is a perfect place for this. Okay, now I want to use this service in our controller. So instead of doing this, I would like to add here public user controller, not repository. I will just add here private final user service. Okay. And instead of that, I will add here user service, and this user service. And we get our first major error. Could not auto wire. No beans of user service type are found. That is because we haven't registered the user repository and user service as beans. So the classes that are managed by the Spring framework. So let's go to our user repository first, and we need to annotate it with the component annotation. So now Spring knows that it's indeed a bin, so the class that should be managed by the Spring inversion of control. Basically, inversion of control system is managing object lifecycles. So it's responsible for creating and destroying objects and also managing them in our application. So we don't have to create new objects using new keyword and provide them in different classes that are needing these objects. So let's register our user repository as component, like we did, and also user service. Okay, and the error should be gone from the controller. Also, it would be better if we actually, instead of using component, we use the alias for the component called repository here. And if you go to the source, it is indeed alias for component. So just for the sake of like readability, when creating a repository, use the repository annotation and do the same thing in the service. Also, instead of using component, use the service annotation just for the sake of it. And in our controller, we can now use our service. So I will just return user service get users, okay? And I will rerun the application and see if it's indeed still working. Okay, we'll restart and we get our new list from the repository. So everything is working fine. If you are serious about learning Java and Spring Boot, join my school community and the Spring Boot Academy, top link in the description. Here is the Spring Boot MVC video that I mentioned before, and you can watch it now. Until the next time, create some amazing applications.